Hey guys, so today I'm gonna show you the very basics of using Seccomp BPF to limit access to your system calls inside your containers. This can help you secure your sandboxes in one of the components that will help you. And so I will be building on top of the default Seccomp policy for or profile for Podman, and I'll be adding some extra syscalls to it to be denied. So let's get into it. So let's do a little test to see if this is working and how it behaves. So for instance, let's enter our base image, which just opens a shell. This is probably the easiest way to test this. So an easy syscall that we can test is the one that is already used by a Linux command with uname-a. As you can see, when I run uname-a, I get all this information, okay? And now let's go into our syscalls and add uname to essentially to the denial list, because this will give you an error. And now let's enter again the base and run uname-a. As you can see, it doesn't even give you an error, it just doesn't show you the full information. So uname tries to fetch that information because there is an internal error. It handles that and just prints the information it has, which is this is a Linux machine, okay? So in order for us to check which permissions uname, which syscalls it is trying to run, we can use strace qsf and give it the command. We can actually not run this here, but let me instead run it on the host, okay? And as you can see, all the syscalls will be listed here. One of them is uname, so this is probably the syscall that will give you all that information, and if you block it, it cannot be used. And this is pretty much all there is about Seccomp, although it can get quite complex for you to, to determine which syscalls you can actually block or not. As you can see, there are multiple syscalls used here. If I block read, I will certainly block other stuff, and let's in fact test it. I don't know if this works or not. If I block read, I'll certainly block uname, okay, from running, but a lot other stuff. Let's test it. See if it even opens, right? It doesn't open. It says operation not permitted. When it tries to open, it needs to read libcrypt, and it cannot, okay, because we disabled reading. So it's not trivial to determine what you can and cannot remove. Let's say that I will remove, I don't know, get random, which is another easy one that shouldn't affect nothing particular. Let's see what happens when we disable get random. Okay, apparently you cannot enter this because there is an error with the crates, which means probably that no needs the random device and it doesn't have access to it. So this can be quite a pain to debug. That's why I looked for a list of the most common ones and just added them. Some of them are already on the default profile. I think user fault fd is actually a part of the default profile. And yeah, as you can see, and it's actually blocked without any other restriction. So I didn't even need to add it, but there you go. This is how you implement a basic Seccomp policy, which is just an addition on top of everything else that we are already doing with containers, with Landlock on Nono, and the upcoming stuff with the firewall and all that. And here you go, a very lightweight introduction to using Seccomp with your Podman containers. Okay, this isn't really that complex. It's just a way to block or allow your system calls to run inside your container, and that's it. Then it's just a matter of syntax and know how to use strace to know which syscalls are being accessed anyway. So until next time, keep developing your systems engineering skills, and I'll see you.